Since the beginning of time, mankind has always looked to the skies in wonder and awe. For most of human history, the movements of the heavenly bodies remained a mystery. It was not until the late 15th century that any sort of interest in taking leaps forward in astronomical advancement became present. Even so, Giordano Bruno was sentenced to death at the end of the 16th century by the Holy Inquisition for suggesting that the universe was infinite and expanding. During this time period, the Roman Catholic Church was the dominating factor in people's lives, and anyone who suggested any science that went against the Bible was punished. Decades later, during a scientific revolution, Isaac Newton published the 3 laws of motion, in which he stated how objects in motion stay in motion because of inertia and gravity.
Every discovery that Newton made had 2 aspects. First, Newton made the discovery, and second, other people had to discover that he had made the discovery.
This in turn raised many questions about the universe because his laws of motion suggested that all matter was constantly moving. However, the theory that the universe was expanding was pushed to the side because astronomers started to focus on the Milky Way galaxy and the immediate world that affected humankind.
During the 1920s, Edwin Hubble brought back the seemingly far-reaching theory about galaxies beyond the mere realms of mankind. Hubble led a revolutionary movement in humanity's knowledge of the universe. His discoveries and evidence for the expanding universe theory have continued to inspire new inventions and theories today.
Edwin Hubble was born in Marshfield, Missouri on November 20th, 1889. He attended the University of Chicago and served in World War I before finally settling down at the Mount Wilson Observatory. There, Hubble worked with the 100-inch Hooker telescope and spent many cold nights trying to feed his curiosity of the universe and come to conclusions about unanswered questions. Hubble took several pictures of spiral nebulae, a type of galaxy consisting of a flat, rotating disk of stars, gas, and dust, and a central concentration of stars known as a bulge. This was quite intelligent, as those images revealed changes over time. He observed instances in which a dim star became brighter as it attracted material from a nearby companion star. On October 4th, 1923, he compared the pictures he had taken of the Andromeda Nebula with photos he had taken on previous nights. In doing so, he identified a Cepheid variable star, which is a kind of star that helps astronomers calculate distances within and beyond the Milky Way. Using the Cepheid, Hubble was able to determine that the Andromeda Nebula was 900,000 light-years away. According to Harlow Shapley, the size of the Milky Way galaxy was 100,000 light-years, and it was the only galaxy that existed. Harlow, along with many other astronomers of the time, believed that all the stars and nebulae were contained within one galaxy, ours. Hubble's new findings proved Shapley wrong because they clearly indicated that the Andromeda galaxy was far beyond the Milky Way. It therefore had to be an entirely different galaxy. This was a groundbreaking conviction, as it suggested that there could also be other galaxies outside the Milky Way. Yet this was neither Hubble's greatest discovery nor his biggest contribution as the leader of a monumental revolution in astronomical thinking. Hubble, working with his assistant Milton Humason, calculated the distance to as many galaxies as possible, and in 1929 he published a paper called A Relation Between Distance and Radial Velocity Among Extragalactic Nebulae, in which he concluded that the universe was expanding. This was such a great discovery that the renowned Albert Einstein personally congratulated and thanked Hubble, as Hubble had proven Einstein's static universe theory to be incorrect, instead showing that the universe indeed was expanding. Some years before, the idea of the Big Bang theory was proposed by Georges Lemaitre. However, he did not have concrete evidence to prove the validity of his theory on how the world was created. Edwin Hubble was the first scientist to provide stronger evidence of what would become known as the Big Bang theory.
Established a very interesting relationship between them. The nebulae that are farther away are moving.
He was able to calculate that galaxies were moving away from us at thousands of miles per second, and that if light emanating from a galaxy was more spread out, the galaxy was moving at a higher velocity. These greater spreads in light can also be referred to as increased redshifts, because light travels in waves and red light has the longest waves. Therefore, these increases in redshifts are proportional to the distance to an object in space from Earth. Hubble's constant, the value representing this proportion, is the ratio of the velocity of the galaxy to its distance from Earth.